All right, welcome back to Elementary Calculus 2. We are going to be looking at problem number 3 for the practice test. So this one, go ahead and blow this up a little bit for you can read it. It says determine the volume of the solid of revolution formed by rotating about the x-axis, the region bounded by the curve f of x equals x e to the negative x between x equals 0 and x equals 2. Okay, so we're going to remember we have x e to the negative x. We're just going to go ahead and write that guy down. So let's see here. Have our, where are we with the pen? Here, right here. So we want to integrate x e to the negative x between 0 and 2, and we want the volume of revolution, which means we have to do pi and then r squared. So you don't have to graph this thing, but what this looks like, we want something like this, and we want to rotate around here. So we're going to be looking at this vase type of a thing here. You have to memorize this formula: pi r squared dx. That's our volume that we're going to be taking here. We're taking one little slice of this and rotating it around. So we're getting the summing up all these tiny little pieces of the cylinder in order to do this. But we know this. We are okay with this. Now this problem, we're going to go ahead and say, okay, we have the pi integral from 0 to 2. We have an x squared e to the negative 2x. Remember your exponent rules to be able to do that, dx. Now, we have polynomial times an exponent. Oh no, that's integration by parts, isn't it? So what we're going to do is we're going to say, okay, let u equal, and you could do tablature integration too, that's fine. So we're going to say let u equals x squared, du equals 2x, dv equals e to the negative 2x, v equals negative 1/2 e to the negative 2x. Okay, so let's go ahead and start that integration. So we have pi all the way out front, don't forget that. And then we have uv minus v du. Okay, so we have negative x squared over 2. That's this negative here, 2 e to the negative 2x minus, but remember it's minus of minus, so we have minus turns into a plus 1/2. Well, actually, no, not 1/2. Let's go ahead and get rid of that because we're going to have 1/2 times 2, so we're going to have plus the integral. This 2 and this 1/2 are going to cancel. X e to the negative 2x. Okay, so minus 1/2. These guys cancel. This is what we left with. And at this point, you say, oh no, there's more integration by parts. Again, we have polynomial times an exponential. So we're going to say, okay, we still need let u equal x, du equals dx, dv equals e to the negative 2x, v equals negative 1/2 e to the negative x, negative 2x rather. So we're going to go ahead and we have to restart this thing. So we have pi. Okay, speaking of restarting, we're going to double check, am I recording? We are. Okay, pi. Negative pi squared over 2 e to the negative 2x plus, and now we have to integrate this because there's no coefficients or anything out here. I'm just going to go with plus. We have uv, so that's going to be minus 1/2 x e to the negative 2x. That's this piece. Minus the integral, but it's really minus a negative, so minus plus 1/2 e to the negative 2x. Okay, and at this point we don't have another polynomial, so we are good to be able to say we're about done here. So let's go ahead one more time just to integrate, not integration by parts anymore, just integrating. We have pi negative x squared over 2 e to the negative 2x minus 1/2 x e to the negative 2x. And then we're going to integrate this. We have minus 1/4 e to the negative 2x. And we are going from 0 to 2. So let me show you a couple of things that we're done with the integral. We don't need a plus c because we have a definite integral. And what we're going to do is I'm going to factor out an e to the negative 2x and a negative sign for each of these pieces. So we have negative e to the negative 2x pi. And what do we have left? We have x squared over 2 plus 1/2 x plus 1/4, 0 to 2. Now let me show you one more little trick for doing definite integrals. We have a negative sign out front times the whole thing. This is also equal to, we can swap the limits of integration. We can say this is e to the negative 2x times pi, and we're going to have x squared over 2 plus 1/2 x plus 1/4. And the negative sign, that swaps our limits of integration. So instead of 0 to 2, we're going to go from 2 to 0. That takes care of the negative sign. Okay, you can use the swapping the limits of integration to eat the negative sign. So the arithmetic might be a little bit easier to deal with. Let's go ahead and evaluate this at x equals 0. So we're going to say this is e to the negative 2, 0. That's going to be 1, right, times pi. And then we've got to plug in 0. We get 0 plus 0 plus 1/4. Okay, so that's what we have over here. Minus, and now we're going to plug in 2. So we have e to the negative, I'll put a pi out here. We have e to the negative 4, 2 times 2. Okay, times, okay, and now I need this piece here. So 2 squared is 4, so we have 4 over 2. Okay, we have plus 2 over 2, we're plugging in the 1/2 here, plus 1/4, and then we'll see about that. The hardest part of doing a lot of these problems is just figuring out, like, okay, we just need to do the arithmetic. So I have pi, actually I'm going to factor the pi all the way out front here, so we'll do that. We have 1/4 here, right? 0 plus 0 plus 1/4, minus the pi came out, so we have e to the 4th. Okay, and now I've got 2 over 4, which is 2 plus 1 plus 1/4. I think we can go ahead and handle that arithmetic here. At least I think we can. So we have pi times 1/4 minus e to the 4th. Actually, it should be e to the negative 4, shouldn't it? Yeah, it should be e to the negative 4. 3 1/4. Okay, so this is 3 1/4. So that's going to be 12. That's going to be 13 quarters, I believe. And leave it like that. So we have pi 1/4 minus 13 quarters e to the negative 4th. If that's going to be our volume of revolution for that item. Okay? So be very careful when you have definite integrals. The indefinite integral, you got to be careful because you know plus c. This one, you got to be careful with the arithmetic. Please take your time doing the arithmetic. Honestly, the hardest steps for these isn't the calculus step, it's the arithmetic step. So be careful with that and just try to go to your own pace to be able to do all of this stuff. Okay? Thank you very much for watching. I'm going to go ahead and stop. Actually, I'll stop share and we'll just end with purple. There we go. Thank you.